All right. Welcome, everyone. I heard I was going on after Gary Vee, and I immediately got really nervous. So we're going to talk about quantum computing. Stay in your seats. I promise it'll be just as interesting. So my name's Greg Price. I'm the CEO and co-founder of Shipwell. And when I was an engineering student at UT, I worked at Pappadeaux's Seafood Kitchen to pay for college. Those first few weeks were incredibly rough. Back and forth to the kitchen for this table over here, getting behind at that one, orders flying at me faster than I could write them down, and then rework, which messed up everyone else's orders. But then something clicked. I learned to batch my tasks, consolidate orders, find the most efficient path through the restaurant, and I increased my service level and cost. I was getting a crash course, and I didn't know it at the time, in supply chain management, and I took on zero debt to do it, right at Pappadeaux's. And supply chains today are incredibly similar. As you guys just saw, you have so many different data sources, so many different modes that you have to contend with. You've got last mile, you've got a Sprinter van, and now you've got different service levels like 2-day, 3-day, same-day shipping, go to the CVS store, just find the person and put the package on them. And so with that, you don't have the tools of computational power and optimization to actually make those decisions in the very narrowing time windows you have to solve them. So I'm going to bring you original content today to show you how quantum computing is going to change the face of supply chain optimization and decisioning. But first, what is Shipwell? So Shipwell is a cloud-based platform that thousands of customers have experienced. Our mission is to put your entire supply chain in a single pane of glass with the ability to adapt on the fly and create a world-class connected experience to your suppliers, your customers, and your carriers. We build automation, visibility, and then we give you the tools to manage everything from drayage all the way to your customer's front door. And we have also one of the largest digital networks in North America today of real-time connected assets. So many of our customers asked us, how could you help us with real-time planning and optimization with the explosion of all these different modes? And so to build the future, one of our core principles, we went out and talked with experts to really understand where the white space was. So Chris, a former trucking and IoT executive, shared that more inventory is on the road than in warehouses. And carriers find themselves a critical link in supply chain. But very few shippers and very few 3PLs take the real-time movements of carriers and the constraints of their network during planning and optimization. Anna shared that capturing relevant data is a start, but you have to be able to capture more of it. And then you've got to use it very efficiently in a timely fashion. And Ryan shared that optimization for carriers is essential to squeak out every bit of margin. But when we went to market, we found that 90% of fleets less than 500 assets use any sort of real-time optimization that takes into things like hours of service, real-time dwell times, and optimizations that would change their operation irreparably. That's the difference of being profitable or falling behind now. So with more data than ever before, coming at you faster than ever before, and your decisions on your carriers, your network, your optimization, and your technology stack, that goes directly into your customer experience. So, and that's coming at you faster than ever before, but you're gonna see shortly, your ability to make decisions quickly, at scale, is slowing down. And the reason why is that computational power has not increased as fast anymore, and with it to solve these really complex optimization problems. So at Shipwell, one of our core behaviors is to build the future and never settle. So we went out and found quantum computing, and we hear a lot about it. But let's figure out and separate fact from fiction and really understand the potential of this technology. First, what is quantum computing? Hold on, I'm gonna do my best here. So traditional computers are like light switches, ones and zeros, off or on for compute and store. They can solve very large, simple problems incredibly fast. Quantum computers are kind of like the dimmer switch in your house. They can take on infinite values, And this opens up new ranges of computational capabilities and shortcuts that you wouldn't get with traditional computers. But if you leave here today, it's simply this. A quantum computer can take very complex problems and solve them to optimality in a matter of seconds. That's what they promise. So to test this theory, we went out and tried to test the traveling salesman problem. And if anyone here knows what the traveling salesman problem is, it's simply this. You take a truck, and you have lots of packages, and you have many locations that you try to get to in the shortest amount of time and cost. And it's actually one of the hardest computational problems to solve at scale, and I'm going to show you what we mean by that. So here's Shipwell's network in Texas, and these are real-time orders and assets that are entering and exiting our network. And on the scale of around 500 assets, 2,000 trailers, 500 drivers, 2,500 orders over a planning horizon of 7 days, that is approximately 1 trillion permutations. And no computer can solve this in days or even weeks. So at Shipwell, we leverage cutting-edge heuristics to solve this problem in around 5 seconds to some level of optimality using real-time networks and the constraints of those carriers. But that's actually a really small problem. A much larger problem and much more complex problem is our national problem. And now that same cutting edge algorithm takes 8 hours to solve, and we don't have that time. And there are over 1 quintillion permutations now. So we had to go back to the drawing board, and we found something that solves in approximately 5 minutes, but it doesn't do it perfectly. So we're leaving money on the table. So what if we were able to solve this perfectly in a matter of seconds? How many billions of dollars? How much capacity do you have to now take off the road? That's what quantum computing promises. So we actually went out and got time on IBM's Q14 Melbourne. 14 is for the number of qubits. And we put the industry's first real-time supply chain problem on a real quantum computer right there to solve this problem. It's hard to visualize, and you can't look at it, but it's a 3-city problem. You have to start somewhere. And what we found is it worked. It solved it to optimality. My entire engineering team was jumping for joy here. So we did what any good engineering team does, and we wanted to push the boundaries to figure out exactly where does the fence post start and stop. And what we found, there are 3 limiting factors right now: the number of qubits, and the quality or error rate of that qubit, and the actual underlying quantum algorithm itself. And the reason why is that you can't take half a truck and half a train to Dallas. So there has to be more development there. And so we drew a curve, and we found that approximately in the range of 5,000 to 10,000 qubits, you're going to be able to solve global scale supply chain problems to some level of optimality in a very short period of time. And we wanted to talk to experts to figure out when is that going to happen. And I'd like to share with you a couple of what they say today. If this video works. Here we go.
So in terms of time scale, what we do know is that the prototypes of today will soon be increased, not just in terms of number of qubits, but quality of qubits. The error rates of those qubits will be improved within the next 12 months, is my expectation, to a point where the quantum computers will surpass the horizon of the capabilities of classical computers.
And the Holy Grail, of course, is something that we are working on currently, which is called quantum error correction. Once you have error correction on top of the natural ability of these quantum bits to maintain their quantumness, then you can go for much longer times, because you can catch errors as they're happening, correct them, and then keep going with your computation. And there are many interesting algorithms to do that. And I think we're getting to a place where we should be able to have some fairly interesting applications within the next few years.
So in terms of time scale.
So what does this mean? This means this isn't decades away. We are on the forefront of this being a reality tomorrow. There are 25 companies working on quantum computers to drastically increase the number of qubits and the quality of them. It's going to change supply chain search optimization, and decisioning, and it will affect how you run your fleet today. And with the explosion of different modes, service levels, you're going to be able to make optimal decisions very quickly. At Shipwell, our mission is to build the future and never settle. We focus on driving drayage all the way to your end customer's door, a world-class customer experience. Thank you to all of my researchers that brought Transparency19 to quantum computing. If you would like to learn more about putting your supply chain on the cutting edge, come see us outside. Thank you so much for your time today.